let's take a look at the Trojan Source vulnerability that was brought to light earlier this week. Essentially, what it boils down to is injecting or inserting Unicode into your code. And then what happens when it compiles is the compiler reads it differently because of the instruction you've put in Unicode. More information can be found here on the Krebs article. A link will be provided for that, as well as on the actual paper. There's a link to the PDF done by Nicholas Barcher and Ross Anderson of University of Cambridge. As you can see, it's multiple languages. There's multiple attack types or techniques rather that you can use. It's all listed here, very well documented. They have noted that they did some scanning on GitHub and didn't find any malicious implementations of it. All the references can be found here as well. I'm going to give you a Python example that was provided in this document here. So quickly to find it and show you the example. Here is a bank account for person Alice with 100 units in. Then you define a function where you specify the account number and the amount. What that then does is take that account and subtracts the amount. So you would call it like account Alice, subtract 50. This is a comment string that says just to the developer, or if anybody else is working on the code, that what this function does is it subtracts funds from the account. Right, now on the left-hand side, you can see the Unicode that's put in here. Now this RLI is an invisible character. What that tells the compiler is to read from right to left. So this return and that semicolon gets put in after the then, right, visually. And then the last part of that is to close that string. Now this looks fine if you look at it from a code perspective, but with this in it, how it looks to the compiler is it sees this and then the return gets called, meaning this won't ever get reached because you're already returning out of this before you even subtract the amount. So places like Stack Overflow, it's very popular for developers to go there for help or for best practice. And then they, and myself included, go and copy the text, paste it right into your application. And this is how it looks with the Unicode on top and with just plain text at the bottom. So you can see they look identical. There's nothing different. The Unicode is actually hiding in here, but you can't see that if you compare these two lines. You're welcome to pause and compare. The code is exactly the same. So I'm going to show you how that looks then. Let's first clear this. All right, let's remove that and paste in the bottom half that I copied from here. All right. And let's give that a run. Cool, so you can see before the withdrawal, Alice has 100 units. After the withdrawal, she has 50 units as expected because you're subtracting 50 units. Now let's copy this and pretend that this is something from Stack Overflow. Right, so take this, paste it in there, and we give it a run. Right, now you see, before withdrawal, after withdrawal. Let me try and get the code in here so you can see both blocks in the same scope, and then hopefully you should be able to see. Yes. All right, this is the one that has no Unicode in it. So look at the string, it's all yellow. Here we have the return as red, and those are slightly grayed out. So it will never reach the scope because it's returning before the actual function. So that's one way you can identify it. Also, if I take my cursor and I scroll to the right, you see I'm still scrolling to the right, but it knows to read from right to left in that instance. So, I mean, if you're looking at thousands and thousands of open source code, you're not necessarily going to spot that. But yeah, hopefully the compilers and the IDEs can sort of build some sort of warning in to say, look, we've detected Unicode in here, be aware of it. But I know that there was a 99-day embargo on this paper being published, so hopefully we should start seeing those things come into play. But yeah, that's it.